Hi there. I'm going to be talking about the trade-off between performance and scalability today. So when I first learned about this, my question was, why exactly is there a trade-off between these two concepts? And so let's dive into it, right? Scalability refers to a system's ability to efficiently service a high load of requests or users. Performance is regardless of the load of users. This could be on a per user basis. How efficiently are we able to serve that individual user, right? And now, in engineering, there's many trade-offs, and this trade-off is the fact that usually when we're handling these requests, we need to balance between trying to support a high amount of users and also being able to efficiently serve a single user, right? Now, but why exactly is there a trade-off here, right? So let's think about a system, and we start off with just a single server hosting some database and whatnot, and we have some requests coming in. And this is how we're serving our user. And now let's say we have just like a few requests coming in, and we want to increase the performance, right? So we want to serve these requests coming in. What we can do is try to vertically scale the system. Now, vertically scale the system refers to increasing the computing resources towards it, adding more money, right? So it's just going to cost us more. And this is typically what you can do to keep your system centralized and increase performance. So we can vertically scale to increase our performance for a single user, right? Okay, so that's fine. Let's say now we've solved our performance issue. Performance, right? Job done, right? But now what happens when we have multiple requests coming in? Suddenly, we hit peak time in our service, and the load increases significantly. Now, despite the fact that we've scaled up, the server is getting bogged down by multiple concurrent requests coming in. So here's where we think about our scalability issue. How good is our system at serving these users at a high load of requests and users? And usually the approach taken for this is, instead of vertically scaling, we horizontally scale. And that means we distribute our computing resources horizontally. So these could be individual servers. And now each server in here doesn't take as much of load requests as opposed to having a single server take all of these requests. And sure, now this system can actually handle a high amount of users much better. So it's been scaled horizontally. However, now, because we need to orchestrate between these different components in this distributed system right here, we've introduced complexity, and as a result, there's latency. So it takes longer to deliver the expected results for a single user, but we can still handle the high load of users. So now we go back to the issue of our performance issue. And this is what we mean when we say we're trying to make a trade-off between scalability and performance. Now, as an engineer, you want to always try to optimize this trade-off. And so typically, you can think of some approaches to try to scale up your system while increasing performance. And so you might want to distribute this load more efficiently so that the server that has you're not distributing requests to a server that's already handling a high amount of users, because then you're just going back to the issue you had with the single server use case. And so you can introduce a load balancer. And you can try to balance this load in a more efficient way towards your servers. And there's various algorithms in here, round robin, fuse connections. Then there's session aware, sticky sessions, another way to call it. But that's a whole separate topic. Another way to try to improve scalability and performance is, suppose that we're storing all our data in some database right here, right? Right? And we're noticed for a lot of these requests, they're requesting like the same data. So it doesn't make sense to hit our database each time if we're requesting the same data. And especially if we have like complex queries in this request. So what might be better to do is, if we notice that the data being requested is consistent, we can simply store it in memory. And as a result of storing it in memory, it's so much more faster to access than having to query it from a database. So this concept is known as caching. And now we're able to retrieve the results for our users much more faster. And so now we can serve our performance issues. So we can do load balancing to handle scaling issues, caching to increase our performance issues. And these are just some techniques. There's many more and much more I'll cover in the upcoming videos. But this is it for now. Thank you.